matrices. So far, addition of matrices, subtraction, scalar multiplication of matrices, how to reference the elements of a given matrix have been discussed. So, should you have missed out on any of these aspects, please, you can check the playlist on matrices, okay, and help yourself with the previous topics that have been discussed. Now, when we talk about multiplication of matrices, this is different from scalar multiplication. Scalar multiplication in one of the videos, like I told you, involves the use of a number, okay, a number to multiply the elements of a given matrix. Alright, so for instance, if K is a scalar, that is a number, okay, and it's multiplying the matrix A. In this case here, K will multiply all the elements in matrix A. Okay, now in the case of multiplication of matrices, okay, we are simply looking at multiplying one matrix by another matrix. For instance, I have matrix A being equal to, let's say, 3, 4, 7, 8, and matrix B being 1, 0, 2, minus 1. So we want to multiply matrix A and B. Okay, so this is exactly what it means when we talk about multiplying matrices. So, how then do we multiply matrices? Okay, first important thing here is that before two or more matrices can be multiplied together, there is a simple rule that must be followed. Okay, so you won't be wasting your time checking whether the matrices can be multiplied together or not. And what is that simple rule? It is called the conformability rule. Conformability rule. Now, for two matrices to be conformable for multiplication, okay, for two matrices to be conformable for multiplication, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Okay, now if matrix A is the matrix having 3 by 2 dimensional order, and matrix B is the matrix having the dimension 2 by 4. Okay, so if the dimension or the order of matrix A is 3 by 2, order of matrix B is 2 by 4, then before we can multiply matrix A by matrix B, we must ensure that the number of columns of A is equal to the number of columns or number of rows of B. The number of columns of A must be equal to the number of rows of B. So the moment the two of them are equal, then it means we can multiply matrix A by matrix B. But the moment the number of columns of A is not equal to the number of rows of B, then it is impossible to multiply matrix A by matrix B. Okay, so in this case here now, matrix AB is the matrix of the order 3 by 2 and 2 by 4. So here, the number of columns of A is equal to the number of rows of B. Now, from this same illustration here, it tells us also the dimension or the order of the product of the matrices A and B. Okay, so when we multiply matrix A by matrix B, also we can tell what the order of the product will be. So this one here will mean that matrix A and B are conformable for multiplication, meaning we can multiply them. Now the leftover dimensions here, this 3 by 4, gives us the dimension of the product. Okay, the dimension or the order of the product of matrix A by matrix B. Now, why is this rule very important? To multiply matrices, okay, to multiply matrices, okay, we multiply, to multiply matrices, multiply the rows of the first matrix, okay, by the columns of the second matrix. This is how we multiply matrices. So to multiply matrices, multiply the rows of the first matrix by the columns of the second matrix. So meaning that when you want to multiply two matrices, okay, the rows of the first matrix will multiply the columns of the second matrix. So if the first matrix is having 3 rows, each row will multiply each column of the second matrix. So now let's look at an example here. Okay, so we're going to take a 2 by 2 matrix for illustration. Now, matrix A is the matrix A11, A12, A21, A22. So matrix B is the matrix B11, B12, B21, B22. Okay, so if we need to multiply matrix A by matrix B, we write that as AB. Now, when you want to multiply matrices, the order of arrangement is very important. Matrix A comes first, matrix B comes next. So, arrange them in that order. A11, A12, A21, A22 times B11, B12, B21, B22. Now, don't forget the rule. They must be conformable. The number of columns of the first matrix, 1 and 2, 2 columns here, must be equal to the number of rows of the second matrix. 1 row, second row. That's conformable. Now, to multiply these two matrices, we follow the fact that the rows will multiply the columns. Okay? So, which means here, the rows of matrix A, A11, A12 will multiply these two columns. When we are done multiplying the two columns here by row 1, we move to row 2. Row 2 also will go through the same process, multiplying column 1, column 2 of the second matrix. So in this case here, we are going to have row 1 multiplying column 1, row 1, column 1. We have row 2, row 1 multiplying column 2, row 1, column 2. Then once we are done with that, we move to row 2. Row 2 times column 1, that is row 2, column 1. Then row 2 again will multiply the second column. Row 2 multiplied by column 2, row 2, column 2. Now, what we are saying here is simple. So for the first one here, we are going to have this, the first multiplication. Okay, we are saying A11, A12, okay, multiplying B11, B21. So this is first row, first column. Okay, first row, first column. Now, in this case here, in this order of appearance as well, the first element here multiplies the first element in the column. The second element in the row multiplies the second element in the column. Okay, so meaning for this now, we are going to have A11 times B11, A11, A11 times, okay, B11, B11. Then this is added to A12 times B21, A12 times B21. So this is for first row, first column. Alright? So if you want to go back for the second one, first row, second column, following what you have there, we have A11, okay, A11, A12 multiplied by B11, B12, that's second column, and B22. So if we multiply this out, this is also saying A11 times B12, A12 times B22. Then we add them. So this will mean A11, B12 plus A12 times B22, A12, B22. So that is for the first row, second column. So now that the first row has completed multiplying the columns of the second matrix, we move to the second row. So second row also will repeat the same process, multiplying column 1 and column 2. So let's see that here. Okay, so in this case here now, for the second row, first column, so we have A21, A22 multiplied by B11, B12. That B21 here, that's first column, okay? B11, B21. So if you multiply this as well, A21 will multiply B11, A22 will multiply B21. So A21 times B11 will give us A21, B11. Then this is added to A22 times B21, A22, B21. So that is for the second row, first column. Now, second row, second column will go the same way. A21, A22 multiplied by B12, B22. So A21 will multiply B12, A22 will multiply B22. Then we sum. So A21 times B12 is A21, B12, then plus A22 times B22, A22, B22. So if we write all of this together, it then means matrix AB is a matrix having, for the first row, first column here, first row, first column, that is A11, B12, okay, plus A12, B22, okay, that's first, okay, sorry, this is the first row, first column, that's A11, B11, okay, that's A11, B11 plus A12, B21, A12, B21. Then first row, second column, that's this, that's A11, B12 plus A12, B22, okay, B22. Then for the next one, second row, first column, we have A21, B11 plus A22, B21. Second row, second column, we have this A21, B12 plus A22, B22. So this is how multiplication of matrices is done. Okay, so now we'll pick one or two examples on this. Now, to multiply matrices, it's not compulsory that the two matrices they have the same dimension. The rule for conformability must be followed. That the number of columns of the first matrix must be equal to the number of rows of the second matrix. Okay, now let's take some examples on this. Okay, so each of these examples, you can pause the video and practice the examples yourself first, and then you compare your answer with whatever we're going to have here. So let's look at this as example 1. We want to find AB if matrix A is the matrix minus 3, 2, 4, 0, matrix B, and matrix B is the matrix, let's say 2, 5, 1, 7. 2, 5, 1, 7. So we want to find matrix AB. So in that case, in the order of appearance here, let's look at the solution. A, B, A comes first, B comes next. And so matrix A, we have minus 3, 2, 4, 0, multiplied by matrix B, which is 2, 5, 1, 7. So if you follow the order of multiplication here, the rows will multiply the column. So minus 3 will multiply 2, 2 will multiply 1 here for first row, first column. So minus 3 times 2, this is minus 3, okay, times 2 plus 2 times 1, 2 times 1, okay, then that's for first row, first column. Now first row, second column will follow the same order. Minus 3 times 5, minus 3 times 5, then 2 times 7, plus 2 times 7. Okay, so we are done with the first row. So move on to the second row now. Second row, we have 4 0, that will also multiply this 2. So 4 multiplied 2, this is 4 times 2 plus 0 times 1. 0 times 1. Okay, then second row, second column also will follow suit. 4 times 5 plus 0 times 7. 4 times 5 plus 0 times 7. So if we simplify this, that now, you can pause the video and complete this yourself first. Then compare the answer with what we have here on the board. Okay, so minus 3 times 2 is minus 6. Minus 6, then plus 2 times 1 is 2. Okay, then minus 3 times 5 is minus 15. Okay, plus 2 times 7, 14. Plus 14. Then 4 times 0 is 8. This is 8. Plus, 4 times 2 is 8. Then 0 times 1 is 0. Then next one, 4 times 5 is 20. This is 20 plus 0 times 7. Okay, 0 times 7, that is 0. So the rest now is to simplify this. Minus 6 plus 2 is minus 4. Minus 15 plus 14 is minus 1. 8 plus 0 is 8. 20 plus 0 is 20. Alright, so this gives us the product of matrix A and B. Okay, where A pre-multiplies B. Pre-multiplication here means that A is coming first, then B is coming second. Alright, so when we multiply a matrix by another matrix, okay, it simply means we need to multiply the rows by the columns. But before you multiply the rows of the first matrix by the columns of the second matrix, you must ensure that the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay, so with that, the matrices do not need to have the same order. Okay, as we have seen here. Now, what if what we have is this? This is another example, and I need you to, okay, to try this also on your own and see if you will get the answer. And I'm very much confident that if you have followed this, you should be able to solve the question, the problem. Now, we have that given that X is the matrix 4, 3, 2, 0, minus 1, 4, okay, and Y is the matrix, okay, we have, let's say we have 4, okay, let me change this to another number, 2, minus 2, 7, 5, okay, so let's look at this. We want to multiply these two matrices. So given X is equal to this, Y is equal to that, we want to find the product of X and Y. Okay, some might write this as X dot Y. It's the same as simply writing X, Y. Okay, so in this case, how then do we find the X, Y? Now, let's check this. If the two matrices are conformable for multiplication, before we start the multiplication process. Okay, so matrix X, matrix Y. So we have 4, 3, 2, 0, minus 1, 4. Okay, multiplying 2, minus 2, 7, and 5. So let's see the dimension of matrix X. The dimension or the order of matrix X is, this is 3 rows, 2 columns. 3 by 2. Okay, that's for X. Y, from what we have here, has 2 rows, 2 columns. 2 by 2. So in this case here, the columns of A, the number of columns of matrix X is equal to the number of rows of matrix Y. So they are conformable. So which means our product as well is expected to be a 3 by 2 matrix. Meaning The product XY must have 3 rows and 2 columns. Alright? So let's multiply this. So if we are to multiply out the matrices, okay, you can pause the video at this point, try to solve the question yourself and see, okay, if you have followed very well, you should be able to do this now. Alright, so let's multiply out straight from here. Now from here, we have 4, 3 for the first row. First column here is 2, 7, so it's paired. We can multiply 4 by 2, 3 by 7, add them together. Okay, now if for instance this matrix Y is having another row here, there would have been an element, okay, extra element to multiply that row. Okay, for instance, let's assume I say this is 0 and 1, for instance here. So having multiplied 4 by 2, 3 by 7, there's no other element in this matrix X to multiply the 0. Okay, so in that case, it tells you they are not conformable for multiplication. So, but in this case here now, they have. So let's multiply out. So this is going to be 4 times 2 plus 3 times 7. 4 times 2 is 8. So we have 8 plus 3 times 7. That is 21. So that is first row, first column. Now first row, second column will follow suit. 4 times minus 2. That's minus 8 plus 3 times 5. That's 15. Okay, so first row is gone. So second row now, we have 2, 0, 2 times 2. That's 4 plus 0 times 7. That's 0. Okay, that's second row, first column. Second row, second column also the same way. 2 times minus 2. That's minus 4 plus 0 times 5. That is 0. So second row is gone from here. Third row now is the next. So minus 1 times 2. That's minus 2 plus 4 times 7. That's 28. Okay, so that's second row, third row, second column, first column. Now, third row, second column will follow the same order. Minus 1 times minus 2. That's 2 plus 4 times 5. That's 20. So the rest is just to simplify the addition operation there. So this 8 plus 21 is 29. Minus 8 plus 15 is 7. 4 plus 0 is 4. Minus 4 plus 0, minus 4. Minus 2 plus 28, that's 26. 2 plus 20 is 22. So if you look at dimension now, 3 rows, 2 columns. That's 3 by 2. Okay, so multiplying matrices, okay, can be very simple. It's not something difficult. But even 1 plus 1 to some students could be very difficult if you don't pay attention to what you are doing. Okay, so what we are saying in essence is to multiply one matrix by another matrix, simply multiply the rows of the first matrix by the columns of the second matrix. But you have to be sure that the number of columns of the first matrix is equal to the number of rows of the second matrix. Alright, so that is this basic rule when it comes to multiplication of matrices. So we can go on and on as well to multiply as many matrices as possible. Now, as a form of an assignment, okay, I need you to do this, okay, as an assignment. You can practice this on your own. We have that number 1, matrix P. Okay, let me just make it 1. Matrix P, if matrix P is the matrix P is the matrix minus 4, 3, 2, 0, 1, 0. And matrix Q is the matrix, okay, is the matrix 7, 8, 9, minus 3, minus 2, minus 1. Okay, so you have to find PQ. Okay, that is the product of matrix P and Q. Okay, and as well, and matrix QP. Don't forget, I've told you, before you set into multiplying one matrix by another, try to check first if these matrices are actually conformable for multiplication, okay, in the order of appearance. So it's very, very important you follow that, okay. So in a case where this order, maybe either PQ or QP is not possible, just note that it's not possible. Definitely you are getting correction to all of this, okay, in the next video. All right, so should you have any question on this, please let me know. Now, one more example that I would say I'm going to give here is when you have a 3 by 3 matrix, the multiplication remains the same. Okay, the multiplication does not differ from other ones. All right, so the only thing is it could be time consuming. So in this example number 3, I'm going to give a simple multiplication here, and I will not be writing every other thing else. So I need you to just follow this. You can pause the video and practice the question on your own. So example number 3. Okay, so we have that, given that, okay, matrix M is 1 0 1 2 4 minus 3 2 1 1, okay, and matrix N is the matrix minus 1 2 3 minus 2 0 0 minus 1 1 5. So we want to find M N. Okay, all right, let me switch it this time. Let's say we're going to find N M. So we want to find the product of the matrix M and N, where N pre-multiplies M. Okay, so let's look at this. Of course, the matrices are conformable. They have the same order. So 3 by 3, 3 by 3. So NM. Don't forget, the order is important. N comes first. So I'm writing the matrix N first. Minus 1, 2, 3. Minus 2, 0, 0. Minus 1, 1, 5. And M comes second. 1, 0, 1. 2, 4. Minus 3, 2, 1, 1. So in this case here, if we multiply this out, minus 1 times 1 is minus 1, 2 times 2 is plus 4, 3 times 2 is, that's 6. Then the first row, second column, minus 1 times 0 is 0, plus 2 times 4 is 8, plus 3 times 1 is 3. Then first row, third column, minus 1 times 1 is minus 1. 2 times minus 3, minus 6. 3 times 3 is, 3 times 1 is plus 3. So first row is gone. Second row now, minus 2 times 1 is minus 2. 0 times 2 plus 0 plus, this is 0 also. Second row, second column, minus 2 times 0 is 0 plus 0 times 4, 0 plus 0 times 1, 0. Okay, then second row, third column, minus 1 times minus 2 times 1, minus 2, 0 times minus 3, 0, 0 times 1, plus 0. So now the third row will come into play. Minus third row, first column, minus 1 times 1 is minus 1. Okay, minus 1. Then 1 times 2 plus 2. 5 times 2 plus 10. Then third row, second column, minus 1 times 0 is 0. Plus 1 times 4 is 4. Plus 5 times 1 is 5. Okay, then third row, third column, minus 1 times 1 is minus 1. 1 times minus 3, minus 3. 5 times 1, this is plus 5. So So we can write the final answer out. -1 plus 4 plus 6. That's -1 plus 4 is 3. 3 plus 6, 9. 0 plus 8 plus 3, 11. -1 minus 6 minus 7. -7 plus 3, -4. -2 plus 0 plus 0, this -2. 0 plus 0 plus 0 is 0. -2 plus 0 plus 0 is -2. Okay, -2. And then the last row, -1 plus 2 is 1. 1 plus 10, 11. 0 plus 4 plus 5 is 9. Okay, then -3 plus -3 minus, sorry, -1 minus 3 minus 4. -4 plus 5 is 1. So this gives us the product for NM. Alright, so with this, I'll conclude the class on multiplication of matrices. So please, if this is your first time of joining this YouTube channel, please subscribe, share the videos, and at the same time recommend the videos to you, your friends, relatives, and every other person around you. Okay, so by doing that, we'll be able to reach larger audience. Alright, so I've said it already that matrix is a playlist on its own. Should you have missed out on any of the topics previously discussed, please watch the playlist and then you can get to understand every other thing that has been discussed before now. So in the next video, we shall be looking at determinants of a matrix.